Okay, guys, so we're continuing with solving systems by substitution. We're just going to take a small step forward. This is actually the last step we're going to take as far as these are concerned until we move on to another method. When you learn the next method, you're actually going to want to use that method to do these problems, okay, which I know some of you might be thinking, well, then why even show me this way? Why don't you just skip to the next method and show me that way? Because there are people out there that like substitution a little bit better, get comfortable with substitution and kind of want to stick with that way. So I like to give everybody as many options as I possibly can. All right, that's the whole idea here is give you more things in your arsenal so you can use them for all types of problems. All right, so if you look at these problems, you'll see right away that we're expected to solve them by substitution. The issue is that we don't have a y equals or an x equals set up for us. So we actually have to do a little rearranging, and it's really not that bad. What you're looking for in these problems right off the bat is a y or an x standing by itself. So for example, number one, that would be this y right here. In number two, that would be this x right here. Okay, so that's what you're looking for. All right, and the reason that's going to make that easy is because that's the equation you're going to rearrange into a y equals or x equals. So if I pull this equation to the side, I have 2x plus y is equal to 7. Okay, I'm going to isolate that y. In other words, I'm going to get it by itself. So I'm going to move this 2x across. Minus 2x. Now I got y is equal to negative 2x plus 7. So there's your y equals. All right, in number two, if I pull this equation out, x plus 2y is equal to negative 4, I would do the exact same thing, just I would move the y term to isolate the x. So I got x is equal to negative 2y minus 4. So now I have an x equals. So now we can substitute. So if I go back to number one, that 2x minus 7, negative 2x plus 7, sorry, is going to go down here and replace this y. Okay, so I now have negative 3x minus 5 parentheses negative 2x plus 7 equals 7, negative 3x. Everything else I'm doing is exactly the same. All right, I just added in a little step. You distribute the negative 5 times negative 2x is plus 10x. Negative 5 times 7 is negative 35 equals 7. Negative 3x and 10x makes 7x. Minus 35 is equal to 7 plus 35 plus 35. 7x is equal to 42. Divide both sides by 7. 42 divided by 7 is 6. So the x coordinate of your answer is going to be 6. Okay. Now you could really take that 6 and plug it in wherever you want. You could plug it into this equation. You could plug it into this equation. The easiest place to go is to take that 6 and put it right there. It's going to give you the answer right away. Negative 2 times 6 plus 7, which is negative 12 plus 7, which is negative 5. So my first answer is 6 comma negative 5. In that second problem, okay, just be careful because now you're plugging in for x. So that negative 2y plus, sorry guys, I got a couple smudge marks there. That negative 2y minus 4 has to replace x. So it's going to be negative 4 times negative 2y minus 4. Minus 4y is equal to 4. Distribute the negative 4. Okay, negative 4 times negative 2y, that's positive 8y. Be careful with your signs. Negative 4 times negative 4 is positive 16. Again, be careful with your signs. Minus 4y is equal to 4. 8y, take away 4y, that's 4y. Plus 16 equals 4. Minus 16 minus 16. Get rid of those smudge marks there. Oop. Okay, so those will cancel. 4y is equal to negative 12. Divide both sides by 4. Y is equal to negative 3. So the y coordinate of your answer is negative 3. Again, like I said before, you could take that -3, you could put it here, or you could put it here. I would go back to the original, or not the original, the one you kind of rearrange, because it's going to give you your answer right away. -2 times -3 minus 4. -2 times -3 is +6, minus 4 is equal to 2. So there's the second half of your answer. Nice and neat. Two nice, neat integer answers. Okay. I know these are a lot of work, guys. I know they take a little bit of time and they're a little tedious. Okay, so if you're skipping steps, if you're not concentrating, right? I'm not saying there's no guarantee I'm not saying you can't get it right, but there's a lot of action going on here. So you really got to be methodical. You got to, show your work. Be careful with your signs. Make sure you're plugging in properly. Make sure you're keeping track of what's X and what's Y. And if you have any questions, make sure you reach out.